this video, we're going to look at circles and ellipses. We're going to write equations of ellipses in standard form. We're going to graph ellipses centered at the origin and not centered at the origin. And then we're going to do some applied problems involving ellipses. So we're going to start out what a conic is. So if you take two right circular cones and you put their tips together like this, and then you slice it with a plane, then you can get four different types of conics. Parabolas, when you slice it like this. Circles, when you slice it perpendicular to the base. An ellipse, when you slice it kind of like you would a circle, but notice how it's kind of tilted, so it's not perpendicular to the base. Parabolas, circles, and ellipses, the plane only hits one of the two cones, but hyperbolas will hit two of the cones, both the top and the bottom cone. We're going to define what a circle is, and you're like, man, I've seen circles. I've seen circles since I was in middle school. Well, that's cool. We're going to just define it again, and then we're going to look at a circle who is not centered at the origin. At this point, you should be familiar with circles centered at the origin, specifically the unit circle. And what a circle is a set of all points in a plane that are a fixed distance from a fixed point called the center. And we're talking about it on a plane. XY plane is where we normally are. When it's not centered at the origin, then it's of this form. X minus h, quantity squared, plus y minus k, the quantity squared, is equal to r squared, where I am centered at h comma k. Now, the thing about this is, and I want you to remember that h always goes with x and k always goes with y, and you're like, how am I ever going to remember that? Well, h is before k in the alphabet, and x is before y in the alphabet, and that's how I always remember it. So h's go with x's, k's go with y's. If I'm asked to find an equation of a circle in standard form, here is the graph right here, and here's the equation. Now this is not in standard form. This up above is standard form. So what I need to do then is I need to complete the square, and I need to complete the square on both the x's and the y's. So when I'm completing the square, the first thing I'm going to do is I'm going to order it so my x terms are together and my y terms are together. So notice I'm just going to rewrite this with my x terms and my y terms grouped together. And then anything that is not, any term that doesn't have an x or a y attached to it as part of the term, that constant, I'm going to bring it to the other side. So I have a minus 32. Now I'm ready to complete the square. So what I do when I complete the square is I take x squared minus 16x, and then I give myself a plus a blank. Because what I need to do is I need to make this, find that value, that blank, that makes it a perfect square trinomial. And then I'm going to do the same thing with my y. So I have y squared plus 14y plus a blank is equal to the negative 32. Well, the thing is that if I add this blank here, if I added this blank here, then I better add a blank here. If I added this blank or this number, I have to add that on this side as well to balance the equation. So the way that I determine what I'm going to add, that blank for the y, is I remember that if I have a minus b squared, this becomes twice a squared, my first term squared, plus twice ab, my first and second term, in my binomial part before it's been expanded out, plus the second term squared. Oh, excuse me, it should be a minus here. I was thinking plus because I wanted to just do the plus as well. Now, if this is a plus, then this is a plus. Okay, so in other words, what I need to do is I need to take this negative 16. So I take the negative 16, I divide it by 2. And if you want, you can do the negative 16x and divide it by 2x. Because notice that I'm doing the negative 2a multiplied by b will give us the middle term. This should give me my middle term, or my b value. So if I take the negative 16x and I divide by the 2x, I'm going to get a b value of 8. Excuse me, negative 8. Now, that's going to tell me what it's going to factor into. So that gives me this term, but it doesn't tell me what I need to add. Now notice I have b squared, so I'm going to take this negative 8 and I'm going to square it. I'm going to add it here, and I'm going to add it to this other side, so negative 8, the quantity squared. So I know that my x squared minus 16x plus negative 8 squared will factor into x minus 8, the quantity squared, which is where I see that 8 there as the h part of my center. And then plus it. I'm going to do the same thing with my 14y. So I'm going to take my 14y, and I'm going to divide by 2 times, I should put that in parentheses, 2 times my first term, which is y. This gives me 7. So that tells me that this is going to be the x, and then it's going to give me x plus 7, the quantity squared. Now, I know that I have to find my b squared, so I know that here this is going to be 7 squared, so over here is going to be 7 squared, and of course right here is the negative 7. You're going to say, wait a minute, you told me that I have x minus 8, but it's a positive 8 there. Well, remember, this goes back to the transformations of graphs. If we think about the fact that if I had x squared, just as an example, so let's go over here and do this example. If this was my function, right, f of x is equal to x squared, we know that this looks like this. It's going to go the vertex of that, well, conic, actually, but we'll talk about this later. That conic is going to go through the point 0, 0. But if I have g of x, is equal to my f of x minus 2, which then becomes x minus 2, the quantity squared. Remember, that graph gets moved over to a positive 2. So that's just a friendly reminder as to why I have the x minus 8, but it is a positive 8 here. I have, that should be a y. Let me erase that, make that a y. I have y plus 7, but I have a negative 7 over here. Now, on the other side of the equal sign, I do need to add the negative 32 plus the 64 plus the 49. Negative 32 is there. The 64 is negative 8 squared, and the 49 is the 7 squared. And I end up with 81. So this tells me, when it's in this form, my center is 8 comma negative 7, and my radius is the square root of 81, so my radius is 9. And that allows me to graph my circle. Now, I want to just stop and talk about conics, circles in particular, and the relationships for ellipses. Every single circle is an ellipse. It's a special ellipse. But that's not true the other way around. It's like when we talk about rectangles and squares, right? Every single square is a rectangle, but not every single rectangle is the square. That also talks about when we talk about numbers. So every single natural number is an integer, but not every integer is a natural number. So you could say that circles is a subset of ellipses. There are lots of applications for ellipses. You're going to see it in the medical field. You're going to see it in whispering galleries, such as the Capitol Building in Washington, D.C., the Mormon Tabernacle in Salt Lake City. Lots of places in which you are going to see the application of ellipses. You're also going to see it when we're talking about travel of planets around a sun or some other celestial body. Satellites travel around the Earth in elliptical orbits. So let's explain what an ellipse is. The way that we define an ellipse is a set of all points on the plane, so xy plane is normally where we are, is the sum whose distances from two fixed points, the foci, so here's a focus and here's a focus, is constant. The center of an ellipse is the midpoint of the segments between the foci. So the center is halfway between, here's where the center is, halfway between this focus and this focus, so that's where the center is. We have the major axes. The major axis is the longer, more stretched part of the ellipse. And then the minor axis is along the shorter or more squished side of the ellipse. So to derive all the equations of the ellipse centered at the origin, I want to start with the origin. We're going to begin with the foci being at negative c and c, comma 0. The ellipse is a set of all points xy so that the sum of the distance xy is a constant. So that tells me if I'm right here, this distance here is the same distance if I add those two sums as if I was at this point over here. So I'm going to call this point A, I'm going to call this point B. that if I add this distance and this distance, its sum will be the same as this distance and this distance. So I know that those marks are used in geometry to show equivalence, but I'm just showing you that those are the two that go together to sum. So using our regular distance formula and some algebra, we're going to get the first equation. So notice here, d1 and d2 for this point x. If I have this point right here, this x1, y1, and then I have this distance and this distance, so I'm going to call this d3 and d4. We know that d1 plus d2 would be equal to the distance d3 plus d4. That's a way that we define an ellipse. So if we have our center at the origin and the major axis is along the x-axis, then the larger number has to be underneath the x squared. And the major axis distance, that number that's underneath the x squared, if I take the square root of it, that is the distance I travel from the center to a major vertice. So our major vertices are at -a and +a because from the center, I'm going the distance a. This is the distance a. Now, this distance, or this value underneath the y, or in this case, the smaller value, when you take the square root of it, that is the distance traveled out along the minor axes, and we get our minor vertices. The length of the major axis is 2 times a, because a plus a is 2 times a. The length of the minor axis is 2b, because it's b plus b. I have y-intercepts, I have the foci. Notice that this is not the Pythagoras' theorem. It is c squared is equal to a squared minus b squared. If it's Pythagoras, it would have been a plus there. So I like to call this the modified Pythagoras. So then that we also get when we are along the major axis along the y-axis, and notice that the a, or the larger number, is now underneath the y. And it doesn't matter the orientation. A is always the distance from the center to the major vertice. And B is always the center to the minor vertice. And it doesn't matter the orientation. Notice the vertices are still have an a in it, except for now it's 0 plus or minus a. My y-intercepts are my minor vertices. And my foci are still plus and minus c, but now instead of being plus and minus c comma 0, it's 0 comma plus and minus c. And this still holds true. The major axis is still 2a and the minor axis is still 2b. Now, when I do these, by the way, I don't remember any of these damn formulas. I just remember the larger number needs to be the orientation of my major. The smaller number needs to be the orientation of my minors. So for this, they're asking me to find the equation, given the information, and then graph the ellipse. So the foci are at positive and negative 2. So this tells me that C is 2. So if I start to sketch this graph, notice that it is plus or minus 2 comma 0. That means my foci are here, where I'm at negative 2 comma 0 and 2 comma 0. That tells me that my my x squared will have the larger denominator value. They also tell me my major axis is 6. Now remember, my major axis is 2a. So 2a must equal 6. That means a must equal 3. So I would go out 3 in this direction and 3 in this direction, and I found my major vertices. I also know, because the orientation, that it's going to be x squared divided by my a squared. So it'll be 3 squared plus y squared. And notice I left a blank because I don't know what b is yet, but I can certainly find b by using this equation. I know that c squared is equal to a squared minus b squared. That means b squared must be equal to a squared minus c squared, just by rearranging. So that tells me that my b must be plus or minus. Now remember, my a squared is 9. My c squared, well, my c was 2, so that'll be 4. So my b squared is plus and minus the square root of 5. So my b squared must be 5, because if b equals plus and minus the square root of 5, if I square it, the plus or the minus, I'm just going to get 5. So I would go up the square root of 5, and I would go down the square root of 5, and then here's an approximate shape, obviously not drawn well, of my ellipse. Now, I have my vertices. They're telling me my vertices are at positive and negative 8, but it is 0, comma. That tells me if I were to start the sketch of my graph, my major vertice is at 0, comma 8, and also at 0, comma negative 8. That tells me my orientation is along the vertical or on the y-axis. That means y squared over 8 squared. I have the x squared over, and I'm going to have to find that in a minute, is equal to 1. Now they tell me that my minor axes is equal to 10. Well, we know that 2 times b is equal to the length of the minor axes. That means that b must be 5. Oh, that tells me that this must be 5 squared here. So I go out 5 in each direction, and I draw my shape. To find my foci, remember that my c squared is going to be equal to 8 squared minus 5 squared, which gives me c squared is equal to 39. So my c is plus and minus the square root of 39. So then my c would be located right here at 0, comma square root of 39, obviously not drawn to scale, and 0, comma negative square root of 39. And then I have found my graph, I found my foci, and I found my equation in standard form. Now the only difference between when I'm centered at the origin and when I'm not centered at the origin is that my center now is, instead of 0, 0, it is h, comma k. That's pretty much it. But that just means also that my vertices are not just the a plus and minus 0 or plus and minus a, comma 0. My foci, instead of being plus and minus c, comma 0, well, I have to take h and add c. I have to take h and subtract c. The length of my major and minors are still the same. Similarly, if I have the equation centered at h, comma k, and my major axis is along the y or parallel to the y, then notice that my larger value a is underneath the y, and my smaller value, which is b, is underneath the x. The length of the majors and minors don't change. The only real difference is that when I find my foci, I take k and add or subtract c. When I find my vertices, I take k and add and subtract a. It's really the only difference. So if I'm asked to graph these and find the foci and all of that jazz, the first thing I'm going to do is look to see, first of all, is it standard form? The answer is yes. These are not quite in standard form. This one's not at all. But this one is in standard form, so I can start pulling off information. The larger number is underneath the y. This tells me that my major is parallel to the y-axis. It's not on the y-axis, but it is parallel. It also tells me my center. My center is 3, comma negative 1. Remember, it's the opposite signs of what's in the parentheses. So I'm going to go ahead and start that graphing. So I'm going to go to positive 3, negative 1. So here's where my center is. Here's my center. I'm going to label that my center. Now from the center, I'm going to count out the square root of 9 in either directions in the y direction. So I'm going to go 1, 2, 3. Here's where my vertex is, and then I go 1, 2, 3. Here's where my other major vertice. Now remember, my center, I'm going to add and subtract that square root of a to the k part to get my vertices. So the y didn't change, so I take negative 1 and I add 3 and I get 2. And I take negative 1 and I subtract 3 and I get negative 4. So there's where my vertices are, my majors. My minor vertices, I need to have this 4, and I'm going to add and subtract 4 from the h part, the square root of 4, excuse me, the square root of 4 from the h part. So in other words, from my center, I'm going to go left 2, 1, 2, and I'm going to go right 2, 1, 2. So my minors are at, now this time my my y value didn't change, so I'm at negative 1. But I'm going to take 3 and I'm going to add 2 and I get 5. And then my other minor over here, I'm going to take 3 and subtract 2, so I get 1, negative 1. So here's what my graph of my ellipse looks like. I haven't found the foci yet, so I do need to do that. So my foci is pretty straightforward. We know that c squared is equal to my a squared, which is 9, minus my b squared, which is 4. So my c squared happens to be the square root of 5, or is 5. It's 5. And then that tells me that c is equal to plus or minus the square root of 5. Now my foci are going to be on this dashed line I just drew. So you can see that my x value does not change. So the location of my foci, which is right here, my foci, is going to be 3 comma negative 1 plus the square root of 5, because remember it gets added to the k. And then my other foci is going to be 3 comma negative 1 minus the square root of 5. And so there is my ellipse and all of the information that I need. B is not in the correct form yet, so before we can even have the conversation of put it in the correct form, I need to divide everything by 16. And when I divide this first term by 16, I end up with 4, because I need to have the coefficient, have it in the correct form, like this one up above. I need to have a 1 in front of the x squared. I need to have a 1 in front of the y squared term. So now it's in the correct form. So I have x minus 3, the quantity squared over 4, plus y plus 2, the quantity squared over 16, is equal to 1. This tells me, since the 16 is underneath the y, that tells me that my major is going to be parallel to the y-axis again. So I'm going to go ahead and start with my center. My center is 3 comma negative 2, so 1, 2, 3, 1, 2. Here's my center. Now I take the square root of 16, and from the center I'm going to add 4 to that negative 2. So I like to draw a dashed line where my major axis is going to be, just to remind myself. So I'm going to take the negative 2 and I'm going to add 4. So I end up here at 3 comma 2. This is where a major vertex is. And then I'm going to take that negative 2 and I'm going to subtract 4. And so I get my other one, which is 3 comma negative 6. To find my minors would be along this dashed line. And my minors are going to go out a direction of 2 in each direction. So my minors, this is a foci or vertex. My minors are going to be at 3 plus 2 more, which is 5 comma negative 2. And I'm going to take 3 and subtract 2, so I get my other minor, which is positive 1 comma negative 2. So now I have the shape, so I can go ahead and draw that in. That's like the best ellipse you've ever seen. I know, you're like, how can I stand how great that ellipse is? Anyways, now I'm going to find my foci. Now remember, my c squared is equal to my a squared minus my b squared. So my c squared is going to be 16 minus 4. So my c is going to be the square root of 12, which can be wrote as 2 root 3. So my foci are going to be here and here approximately, and so it's going to be 3 comma negative 2 plus 2 root 3, and 3 comma negative 2 minus 2 root 3. So those are all the pieces that I need to graph my ellipse. Let's take a look at C and D. C and D, well, C and D, neither one of them are really nice because I have to complete the square. So I'm just going to zoom in so I can have more space this way. So the first thing I'm going to do is, I'm going to write this as x squared plus 6x plus 9y squared minus 18y is equal to negative 9. I do x squared plus 6x plus a blank. Now here I have to factor out a 9 because in standard form I need to have my y squared have a coefficient of 1. So I have y squared minus 2y plus something is equal to negative 9. So I'm going to do that plus something in blue. Now, I have to balance it, so what I added to complete the square on the x has to be added here. And then to add what I need to balance for what I add for the y, I need a 9 multiplied by that x, because I have 9 multiplied by this blank value. This blank value is what is going to complete the square. So I have to remember I have to do 9 times that blank, and that's really important. Okay, so as before, I take this 6x, divide by 2x. This gives me 3. That tells me this is going to factor into x plus 3, the quantity squared. That tells me I'm going to add 3 squared, or 9 here. I'm going to add 9 there. I'm going to take this negative 2y, divide by 2y, and I get 1. That means this becomes 9y minus 1, the quantity squared is equal to. So I'm going to add 1 here. So that means I'm going to put 1 in that blank spot. When I get done taking negative 9 plus another 9, I end up with 9. Now, it's not quite the right form, so I now need to put in the right form. So I'm going to divide everything by 9. So I have x plus 3, the quantity squared, divided by 9. When I divide this second term by 9, the 9's will cancel, leaving me y plus 1, the quantity squared, over 1 is equal to 1. And now I'm ready to graph this. My center is negative 3 and positive 1, so here's my center. The larger number is underneath the y, so my major is going to be along this dashed line. And my major from that center, here's my center. My center is the point. The center is the point negative 3, 1. From my center, I'm going to add and subtract 3 in the x direction. So if I subtract 3, my first foci over here is going to be negative 6, 1. And then I'm going to subtract 3, and I get the other, not foci, my vertex, my vertex is the 0, 1. Now, my minors, I'm going to go out 1 in each direction. Here's the axes for my minors. So I'm going to go up 1 and I'm going to go down 1. So my minor vertice happens at negative 3, 2 and at negative 3, 0. So here's my graph. I still need to find my foci. So my foci is going to be c squared is equal to a squared minus b squared. So c squared is going to be equal to 9 minus 1. So c squared is equal to 8. That tells me that c is plus or minus square root of 8, which is 2 root 2. So my foci will be here and here. So the foci right here is going to be, now I'm going to add and subtract from that negative 3. So negative 3 plus 2 root 2, 1. And my other foci here is going to be negative 3 minus 2 root 2, 1. And now I found all the pieces and drew my graph. This last example, I'm going to need to complete the square on both the x's. So I have 4x squared plus 8x plus 3y squared minus 6y is equal to 5, and I wrote 8. And 5 is already on the other side of the equal sign, so that's a cool place for it. So I have 4, don't forget I need to factor out the 4x squared plus 2x plus, I have my blank, plus 3, and then y squared minus 2y plus this blank is equal to 5 plus. I need 4 times the first blank, because there's that coefficient of 4 right here. And I need 3 times the second blank, because that coefficient of 3. So once again, I take this 2x, I divide by 2x, I get 1. So I know I'm adding 1 here and 1 in that blank. This becomes 4. X plus 1, the quantity squared, plus 3. And I take this negative 2y, divide by 2y, I get 1, negative 1. So I'm going to add negative 1 squared, which is 1. So I'm going to add a 1 right there. This becomes y minus 1. The quantity squared is equal to. On the other side, I have 5 plus 4, which is 9, plus 3 more, which is 12. Still not in the right form, but we are getting closer. Divide everything by 4, and I get x plus 1, the quantity squared, divided by, well, 12 and 4 reduced to 3. And then I have y minus 1, the quantity squared, and the 12 and the 3 reduced to 4, which is equal to 1. Now notice that my 4 is the larger number and it's underneath the y. So that tells me my graph is going to run parallel to the y-axis. My center is -1, +1. So here's where my center is. My major is going to be running along the parallel to the y-axis. And I'm going to go up 1. So here's my center. My center again is the point -1, 1. I'm going to go up 2 and down 2 because I have 4 and I take the square root of that. So I'm going to go up 2 and down 2. So here's where my first vertice is. It is -1, 3. And my second vertice is right here, which is -1, -1. And again, I found that by adding and subtracting 2 to the y part because I'm running parallel to the y. My x part is the square root of 3, so that's always fun. So I'm going to go the square root of 3, which is slightly more than 1, but less than 2. So it's probably about right here and probably about right there. So this is going to be the square root, it's going to be -1 plus the square root of 3, 1. These are my minors. And this is going to be -1 minus the square root of 3, 1. Those are my minor vertices. So I know what my graph is going to look like, something like that. Still need to find my foci, of course. And so my foci is going to be the c squared is equal to a squared minus b squared. So c squared is equal to 4 minus 3. So c is plus and minus 1. Oh, this is the first time we had a really nice focus. So my focus, I'm going to go up 1 and down 1. And so this focus right here, this focus is going to be -1, 2. And then this focus is going to be, obviously not drawn to scale because it should be right there. It will be -1, 0. And now I've found everything that I need to graph my ellipse. I've graphed my ellipse. I found my centers, I found my major and minor vertices, and I found my focus. So for these, we're going to find the equation with the given information and then graph the equation. So the center is 2, -2. So we know that this is x minus 2, the quantity squared over something, plus y plus 2, the quantity squared over something, is equal to 1. So I'm going to start the graphing part first so I know my orientation. My center is +2, -2. So here's where my center is. My vertex, and they're giving me, when I see vertex, it is assumed major, is 7, -2. Notice that the y's didn't change. If the y's didn't change, that tells me that my major is running parallel to the x-axis. So my vertex is 7, -2. So I went from 2, I went 1, 2, 3, 4, 5. I went a distance of 5 to this vertex, which is 7, -2. Remember that distance from the center to a vertex is my a value. So I went a distance of 5, so I know this must be 25. That tells me that I have to go back 5. So 1, 2, 3, 4, 5. Here is my other vertex. So I have -3, -2. There's where my second vertex is. Now, I have a foci. One of the foci is at 4, -2. And this also tells me I'm going in the right direction because, again, the y did not change. That means I must be running parallel to the x-axis for my major vertice. So if I go 4, -2, here's where my focus is, 4, -2. That tells me the distance I traveled from C to my center to my foci is C. So C must be 2. So since C is 2, that means I go back and here's where my other focus is. Here's 1 and here's the other. Now all I have to do is figure out what my B value is. Remember that C squared is equal to A squared minus B squared. That means B squared must be equal to A squared minus C squared. B squared must be equal to A squared was 25. C is 2, so that must be 4. So B squared must be 21. That means B is equal to plus and minus the square root of 21. Now 21 is what they're looking for, but I still need to find my minors. My minors are going to be on this dashed green line. So now the 2 doesn't change, but the -2 does. So I'm going to have -2 plus the square root of 21. So it's going to be somewhere about right here. So my minor is negative, or excuse me, 2 plus negative 2 plus the square root of 21. My other minor is down here, so it is 2 comma negative 2 minus the square root of 21. And here is my ellipse. Not drawn to scale, mind you. All right, so let's take a look at these last two, and I'm just going to give you the answers, and I hope that if you have questions that you come in, but it's going to be similar to what I did before. And they tell me where the foci are, right? So these tell me where the foci are. So in other words, if I find the distance between these two, notice again that my y's don't change. And the distance I traveled from -1 to 5 is a distance of 6. This is equal to 2 times c. They also tell me my major axes, which is 2 times a, is equal to 8. And that should be able to help you get started so you can finish that one off. Again, I'm going to look at this one. Notice how my y values are not changing. So I know the distance traveled from the center to the focus is 3, so that is c. So my c is equal to 3. And it contains the point 1, 3. Notice that this one and this one are the same. So that's going to help you a little bit. If you were to graph this thing, I'm just going to get you started on this. If you were to graph this, the center is at 1, 2. So here's the center. But it also contains the point 1, 3. Oh, that must tell me, if it contains that point, 1, 3, that must tell me my b value. So here is my b value. So they're giving me the c value on this, and they're giving me the b value on this. So I'll let you finish those off. Eccentricity is defined as, for us at this point, we're going to continue to redefine a little bit, as the ratio of my c value, the distance from the center to the foci, divided by my a value, which is the distance at this point. The distance is, a is the distance from the center to a major vertice. Now, my eccentricity is always going to be for c being less than a. And I have to say c being less than a because when we get into hyperbolas, c is not going to be less than a. But right now, in ellipses, it's true. And that tells me that e, my eccentricity, is less than 1 for these type of conics, these ellipses. When e is close to 1, the ellipse is skinny, almost flat. When e is close to 0, it's almost a circle. So when e is equal to 0, then we actually have a circle, but eccentricity doesn't really count at this point for circles. Anyways, if I were to make a guess which one has the smaller eccentricity, it would have to be this one, because this one would have an eccentricity closer to 0, but this one would be closer to 1. We're going to look at eccentricity again when we look in polar coordinates. It's going to make a lot more sense when we get there, but I just wanted to take a moment and speak about eccentricity. And that's it for, oh, you probably want the answers back up here. So let's go back up here so I can give you the answers. So let me do this really fast. Lock that rotation. Let's go back and give you the answers here. For b, the equation should be x minus 2, the quantity squared, over 16. And then plus y minus 1, the quantity squared, over 7 is equal to 1. And you're going to think, how did I get the center? Remember, the center is halfway between these two. And this gives me c, this gives me a. Therefore, I can find b by taking half of this and squaring it, taking half of this 6 and squaring it and subtracting the 2. And so I end up with the 7 here. And for this other one, I told you I'd give you the answer for this other one, and it is x minus 1, the quantity squared, over, now the distance between the foci and the center is 3, so that's 3 squared would be giving me my c squared. The distance from my center to that point, which happens to be my minor vertex, is 1. So basically I have 3 squared plus 1, which gives me 10. That would be my a squared. And then plus the y minus 2, the quantity squared over 1 is equal to 1. So there's all the answers. And that's it for this video.